Hi guys, I'm Pat Kelly. Okay, in this problem, they give us this model for a power cable suspended from two towers. They tell us that. We have a restricted domain. They ask us to do three things. They ask us to graph the model. They ask us what the height of the cable is at each of the towers, as well as at the midpoint. And then finally, they want to know what the slope of that cable is at the right-hand tower. Okay, you might want to grab a calculator too, because there are going to be some computations involved. Now part A says to graph the model. I've already got my axes ready to go. And I would suggest to you that you should know the basic shape of this graph, okay, right? Because one of the main lessons here has been this hyperbolic cosine and how that looks like a cable suspended from two towers. Perfect. So you know it's somewhat like a parabola, but I'm not going to graph it yet because I'd like to be a little bit more specific. You know the basic shape, but we'll be more specific with the graph once we know the height of this cable at the two towers as well as at the midpoint. So let's go to part B of this problem first, and we'll come back in and draw a nice graph for part A in a minute. For part B, we're just looking for the actual height of the cable, and that's exactly what this equation gives me. Okay, so at the two different towers, we'd have one at -15 and one at +15. All I need to do is to find the y value at each of those x values. So y of -15. That's why I had said to grab your calculator, because you're just going to take this equation and put a -15 in for x. And it only appears one place right there. So a little bit of stuff in your head. Realize all you're going to put in your calculator is 10 plus 15 times the hyperbolic cosine of -1, right? Okay, so grab your calculator. And at this point in your work, if you've been doing your homework, you've probably already gone to your calculator or a graphing utility or something for these hyperbolic trig functions. And if not, then I need to tell you that you're not going to find this cosh on a key or in a menu choice typically on one of your calculators. So you might have to dig through a catalog or deep menu choice. So for me, what I'm entering here is 10 plus 15 times, and I've got to go to my catalog and then bring up the C's and look down until I see COSH, enter, -1. Then hit enter, and I am getting a value over here then of approximately 33 and 15/100ths. Okay. All right, and that's only my left-hand tower, so I'll also do my right-hand tower very similarly. A y at a +15 for x. And I am again going to rely on my calculator. Now I'm doing 10 plus 15 times. Got to bring up that cosh again. And then a little bit in my head is 15 over 15 is obviously 1. So I only need 1 as my argument for the hyperbolic cosine. Hit enter. I should have seen that coming. There's symmetry here again, right? Because you know the cable hanging from those two towers is going to hang at the same height on the right and on the left. Okay. Finally, for part B, they wanted me to find the height of the cable at the midpoint, and that's actually just another calculation here, y of 0, right? Right between our two towers, x of 0. So here we're actually putting in a 0 for x. I'm still going to rely on my calculator because it's still going to involve that hyperbolic cosine. This time, 10 plus 15 times, bring up that cosh again, and 0 over 15, obviously 0, that you're entering as the argument of cosh, and I'm getting an answer of 25. If you could do that one in your head, the cosh of 0 is actually 1, so 10 plus 15, that's why we're getting a 25. Okay, now I get to go back, and part A, I told you we'd come back to it. We can graph this with a much better feel for where the cable is hanging from and how far down it's hanging, because I have these points. negative 15, comma 33.15. You do realize these are XY points here, right? Negative 15, comma 33.15. So in my graph, negative 15, 33, right about there. Okay. Similarly, 15, comma 33.15. So here and up. And finally, 0, comma 25. That would be about here. And I'll try to draw my best hanging cable. That's it. That's it for part A and actually part B. Part C, they want us to find the slope of that cable at the right-hand tower. So right there. And the slope of our tangent line to a curve is, as always, the derivative. Right? So here's where a little bit of the calculus comes in for part C. What I need to do is take my y equals, I'll rewrite it just so it's more convenient for me down here. And as I mentioned, the calculus is we just need to differentiate. Part of the new material for sure. We're going to have to differentiate something that involves this hyperbolic cosine. Okay, well, if I differentiate, that of course goes to 0. This coefficient of 15 would still be there. But when I differentiate the hyperbolic cosine, that's the hyperbolic sine of the same argument, x over 15. But then I would multiply by the derivative of x over 15, which is 1 over 15, which is actually conveniently going to cross out this 15. They'll divide out. Okay? So that's actually my derivative, hyperbolic sine of x over 15. That's good. That's my derivative. But specifically, they want to know the slope at that right-hand tower. Okay? So that means I just want y prime at 15. So I'm putting a 15 here for x. I won't write this. I'll do a little bit of math in my head again. 15 over 15 is 1. So I just need the hyperbolic sine of 1. Did you notice I had my hand on the calculator the whole time? So I still need it. I'm just going to do the hyperbolic sine, which again, you're probably going to have to dig through your catalog or something comparable for SINH. So I'll go down to my S's here. And my argument is just simply 1. And I am getting approximately 1.175. Had to round. Okay? That's what our slope would be of this cable at the right-hand tower. Okay, that should complete the problem. You should be able to do some more on your own now.